Let's continue. Now, with this in mind, we understand now the steps. First, okay, start with the acid. Any acid, you can use this here. And then step number 2, we're going to add either the metal or the base or carbonate slowly. And then mix, okay, or stir until metal or base or carbonate dissolves. That is why we need to add this slowly to make sure that we have enough time for metal or base or carbonate to dissolve with the acid. Okay, now if we add them little by little, let's say few grams over a few grams, okay, initially the metal or base or carbonate, they're going to disappear, no longer one. But in the end, when the metal or base or carbonate, okay, not dissolve, okay, until long time, stop adding. This means already in excess. When we have an acid, what we have is just an acid. When we add metal carbonate, we have acid, okay, base, and salt. When we are dissolving, the base is going to go out, so we have only acid and salt. So this is what happened in the liquid. Start with an acid here. When you have a base slowly, you have a base. And with that, you have a salt. As long as there is any acid, base is going to react with them. So no base left. What we have is just the salt. In this case, we see on the third stage here, we say that acid is in excess. There are more acid than base available. So all the base react, but still some acid left. We say acid is in excess. Of course, we have salt also. We cannot stop in this condition because in liquid, we have mixture. There are salt, there are acid. But we want to have pure salt. Now, when we have in part number 4, we have acid base long time, it means that after acid, base, and salt, it is the acid that goes out. So only base and salt. I repeat, initially we have just an acid. When we add a base here, acid and base, okay, I think I'm better here. The acid and base change into a salt. So in the liquid, we have only acid and salt, no base. All the base react. But if you keep adding base, there will be condition when all the acid reacts. And because of that, the base stays in the liquid. No longer how long we mix them, no longer how long we stir them, the base is not going to vanish. They're not going to dissolve because there are no more acids to react with them. In this case, we have in the liquid base and salt. Okay. The next step here, we are going to filter Okay, the excess base, excess metal, or base or carbonate. If you filter them, then we have only the salt in the liquid. And that's it. Okay. Hello?
Yeah.
Okay.
Yeah.
Okay. Now, most of the time, you are asked to make the salt into powder. So what we do next is we are going to heat salt until dry. Okay. Usually not until dry, and then use filter paper. Filter paper is used to absorb the last moisture. It is dangerous to make acid until dry in a crucible. Why? Because sometimes there is reactions. When acid gets heated, it is possible for them to react, decompose, okay, and make some dangerous gases. So most teacher will tell you stop stop heating when we see most crystals with a little water left. You are going to do it the way the salt makers do it traditionally. Salt makers is going to take the seawater, they're going to dry them on the under the sun, okay, and they're going to have the white crystal of salt water, sea salt, but we're not going to get them until very dry under heat, under fire, because it's dangerous. Sometimes they're going to have little explosions. Depends on the type of salt you work with. So for the safety, you have the salt with a little bit water left. Then you are going to pour them on a filter paper. The filter paper is going to absorb the last of the salt. Then you oven it, not burn it under fire, oven it. And then oven to dry. Oven is not hot enough to make any chemical reaction. They're just hot enough to dry them. The way you are using hair dryer. Hair dryer is going to make your hair dry, but it's not going to burn it. So in this case here, we're going to have salt, but the solid salt. Ta-da! That's it. Long, yeah? Okay, so those are the steps we need to do in order to make a salt soluble from acid with base or carbonate or metal. Any question? We start with an acid. Okay. Step 2, we pour metal or base or carbonate, pour them in. Step 3, okay, we are going to mix them. Okay. Keep adding and mix it, but do it separate. So add a bit, mix, stop. See, nothing left. Add a bit, mix. Okay. When there are some excess here, okay, we are going to pour them on a filter paper. Filter paper. You can get rid of the residue here, but we're going to take this one here. It's going to be salt. The salt here, we're going to fire up until there are a little bit of water with some salt here, salt liquid. And then you're going to pour them on the filter paper. And in some schools, if you have them, you oven it. If you don't have oven, you just leave them on a sunlight, or just leave them on the room temperature. Okay, what we have is going to be pure powder of pure salt. Ta-da! Oh, sorry. Use filter paper is usually step number 7. My bad. Oven to dry. You have them. That's optional. Okay, that's it. Rather than trying to memorize the steps here, try to imagine in your head what happens in each step. Because if you get the logic, you don't need to memorize at all. You see the logic behind it. When we add water here, we have acid plus salt. When we have them here, we have salt and we have the base here. After we filtering here, the base stays in the paper, the salt become pure. Then we're going to heat the salt here until we have salt solid with a little water left. You can, if you want, dry them with a filter paper and then oven it. Otherwise, just dry it with filter paper. Do not, I repeat, do not heat until totally dry. It is not safe. But if your teacher knows what is the salt and he or she deem it to be okay to dry them, okay, you can dry them. In general, if you are not sure what is the salt, some salt is going to decompose with strong heat and they're going to release toxic gases. That's why don't do it until dry unless you know it's safe. Okay. Question?
Nope.
No. Okay. Now, some notes. First, okay, unlike the question number 4 here, do not wash with water. Okay. In the question number 4, when we are going to make insoluble salt, there is a step that we are going to wash with water in order to make a pure salt. Do not do this in case of soluble salt. Why? When you add water, the salt is going to dissolve and all of your hard work is going to wash away. And then do not heat, okay, until totally dry unless, okay, salt is safe. And the third one here, we need to know that there are some exceptions for the metal. Platinum, gold, silver, mercury, and copper. So this method cannot be used for noble metal. Why? Because they cannot react with acid, normal acid. There are a special acid that can react with them. But normally, if we say normal acid in laboratory, they will not react with any of this. Okay, example. Question will be, outline steps to prepare pure, okay, what happened here? Let's say we must have a carbonate here. Magnesium sulfate, okay, from acid and carbonate. Example, the question may ask you, outline steps to prepare pure magnesium sulfate from acid and carbonate. Okay. Of course, okay, answer. We need to know what is the acid and what is the carbonate. The acid we use, okay, must come from the anion part, the sulfate here. That's going to be sulfuric acid. And the carbonate we use here, we know the carbonate already. The front part goes for the magnesium. So the acid comes from the anion. The cation goes to the carbonate. So we're going to use sulfuric acid and magnesium carbonate. Step 1. Put sulfuric acid in a beaker, or you can also have either beaker or conical flask. Step 2. Okay. Put little magnesium carbonate. And 3. Shake or stir until all MgCO3 dissolve. And then repeat, okay, step 2 and 3 until MgCO3 persists. When they persist here, what we do is, okay, filter the solution, okay, discard residue, take the filtrate. 6. Heat filtrate until, okay, only little water left, until crystals form and little water left. 7. Dry crystals in filter paper. That's it. If you want, you can add oven the crystal to dryness. Ta-da! What do you say? Is it understandable now?
Yeah.
This is the second hardest to do. The easiest will be question number 4. The hardest is question number 1. Okay, if that is okay, then we can go to case number 2. This one's done. We know here how to make soluble salt from acid with either metal or base or carbonate. We all pour them with the same word as base, okay? Because all three of them, metal or base or carbonates plus acid makes salt. Okay. Now let's go to question 3, part B. Okay, let's do question 3, part B now. Case 1. Case 1. Acid plus alkali make soluble salt. This is question 3B. Okay. Now, before we go here, let's see the problem we have here. In chemistry, in acid and base chemistry, in acid and base, reaction always goes until one of the reactant runs out. So if you have A plus B, okay, makes any C here. If you pour A plus B, you never have in the end A plus B plus C. It's never possible. Why? Because either A is in excess or B is in excess. But we don't have A and B both in excess. As long as there is any left of A and B, they're going to react. In the first case here, we rely on this case to make cases that make them until B plus C. As long as we add more and more base until they are not reacting anymore, we can be sure from the theory, no acid will be left, only base. But in this case, we have to make sure that not A nor B is in excess, only C was left. So the key here is finding the ratio between A and B until both of them react and none in excess. Why? Because in this case, they are liquid, liquid, and liquid. Acid and alkali is liquid. They are soluble in water. The result is salt, which already written, it has to be soluble. So we have liquid and liquid and liquid. We have three possibilities. First, there are acid mixed with the salt. There are possibility also of base mixed with salt. If we put too much acid, not enough base, then acid will be in excess. Our salt will not be pure. If we put too much base, acid not enough, the result will be not pure. So if we have them here, we must have such condition how to make A and B in a correct ratio, both annihilate each other, nothing left. This is the pure. To do that, we have the case that we call titration. What is titration, by the way? Titration is method to find equivalent volume of acid and base. Equivalent means they are just enough to react with each other. Okay. In this case, we don't need to know what is the concentration of acid and base. We just need to know, okay, I have this acid and I have this base. Okay. Find out what is the ratio between them so that they're going to annihilate each other. Okay. How to do that? Okay. Now, I'm going to make the steps in simple, right? Okay. Steps 1. Okay. Do titration. Okay. To find correct ratio of A and B. And the second, okay, we mix, okay, A plus B with the correct ratio. Bear in mind that in this case, the acid and base we use in titration, we are going to throw them away. We are not going to use them. They are going to be sacrificed just to have the information what is the correct ratio. But the result of the titration, we're going to throw them away. This is the important. This unlike the previous cases here. Okay, this is the unique one here. We're going to make one experiment to find the ratio, but that experiment we're not going to use. We're going to throw away. Okay, and then we're going to dry the solution. Just like the previous one. Okay, not dry the solution, heat the solution. Heat the solution. Okay, dry with filter paper. Do not wash. Okay, that's it. Actually, it's very simple. The key idea is first, find the correct ratio by doing titration. Okay, throw that away. Second, take the ratio and determine how many salt you want to make. Do you want to make them in large scale or just a small number of salt? It's up to you, but keep the ratio. Third, after mixing, you can be sure, okay, that in the salt there, I think we have to, I forgot to say to stir it. Okay, I'll put number 3, this is 4, and this is 5. Okay. We are going to stir the solution. You will never see any precipitate in the case here. You will always see just liquid as if nothing happens. So we have to rely on our chemical understanding of what actually happening here. So we have them here, A plus B becomes salt and then throw away. And then we have A plus B. After mixing, we have just S. Hit the solutions, we have S, but then we have them in solid. And then we have them here. just as solid. Okay, it's easy, but we need to know how to do titration. Now, this is the only case that we must have numerical number here. And on all the other cases here, we don't need to know about numbers. But in this case here, we need to check the numbers. We have to put a known volume of alkali in beaker or flask. Okay. And then why it is alkali in the flask and not the acid? Why it's not the other way around? Why not put acid in the flask and put the alkali on the burette? Alkali, they can precipitate. Even if they are soluble, they actually don't want to dissolve. Sometimes they're going to precipitate and they're going to jam the burette. Acid will not do that. Acid is essentially always be liquid. So they're not going to turn into solid, precipitate, and jam the burette. So if you put the alkali there, it's possible that, especially if you left them for some times, the alkali is going to make some deposition on the glasswares, and it's going to make them unusable. Sometimes they are going to break them up because it is so hard to free them. Put the acid in the burette. Okay, don't forget to read the initial volume. You need to know what is initially how many acid we put them here. And that step 3, add indicator. Indicator into the beaker or the flask. What is indicator again? Okay. Indicator is a dye it is a coloring agent, a dye that is going to change color in acidic or base condition. Don't forget, okay, check the color. Don't forget to check the color. After you add the indicator, okay, you can use them to make sure that it is alkali that you put in the beaker, not the acid, not the other way around. And for here, okay, slowly add the acid, okay, and mix until color revert back. If you add the acid, okay, in the area when the acid hits the beaker, you will see that the solution change color from the color of basic to color of acidic condition. So for a while, you're going to see as if you have a mixture of colors. But if you mix them here and the water become homogeneous, the color is going to revert back into the normal basic color. When the color change persists, stop adding acid. In reality, we usually do titration at least 3 times. The first, we're going to have what we call rough titration. In rough titrations, we're going to add the acid in large increment, like 1 cubic centimeter. So we're going to put 1 cubic centimeter, stop, mix. 1 cubic centimeter, stop, mix. Keep doing them until at one times the color change. Okay. Almost always that is already overshoot. Note that and then redo again. Okay. But we are going to redo it until the nearby condition. Okay. After the color change here, okay, note the final volume. And then calculate volume of acid added. This is inconsistent with most physical condition here. We have the final minus the initial. So you will see in burette, when burette is full, it reaches 0. When the burette is almost empty, it reaches 50. Normally, you're going to see the condition. When they are full, it's 50, right? When empty, it's 0. It's a normal condition. But in burette, you are going to see the grading is upside down. When the burette is full, totally full, maximum, it's going to read 0 milliliters. When they are almost empty at the very back, you're going to see 50 milliliters. All burette has 50 milliliters capacity. It's standard. So don't get confused why it is the other way around. It's because we are going to use this formula. So the final number must be bigger than the initial number. Okay. The end of this is step 8. We want to find the ratio. What is V added plus V base?